Hello and welcome back, my loves. Today we are talking about two-step inequalities. So if you need a reminder of how we do two-step equations, go ahead and jump back to those notes, that video. Two-step inequalities, very, very similar. The number one thing you want to remember is what happens when we are multiplying or dividing by a negative number. So what happens to that inequality symbol when we multiply or divide by a negative number? Our learning target today is that I can solve two-step inequalities. So we are going to be using those symbols greater than, less than, greater than or equal to, and less than or equal to. And because we're doing inequalities, we are going to have to be using our graphs today, which means we need to remember, are we using an open dot or are we using a closed dot? So if you need to pull open your notes from one-step inequalities, because remember, that's where all of those notes are, that's where that chart is for what type of dot we have, then I would go ahead and pull that open, give yourself a little bit of a refresher, and then come back to this. Okay? So let's go ahead and dive right on in to this very first problem. We have 2a plus 4 is greater than or equal to 24. We're going to continue using tables today. And I'm going to go ahead and get it all set up for us. Why don't you go ahead and get your table set up and see if you can solve this inequality the same way we would solve a two-step equation. All right, here we go. Our table is set up. The very first thing we need to do is identify that variable. In this inequality, our variable is a. So we're just going to put an a there. And the very first thing that is happening, the closest thing that is happening to that a, is times 2. Because remember, when a variable is touching the number that it's right next to, that means multiplication. That is our coefficient. So we have times 2. And then next to that, we have a plus 4. So we're going to add 4 next. Following our life cycle around, we have to remember, we're trying to start with the variable, the first thing that's happening, second thing that's happening, and we're going to follow it around in a circle in the same direction. So the very first thing we need to undo is that plus 4. So that inverse or opposite of plus 4 is minus 4. And then when we follow that circle around, we get to our next inverse. The inverse of times 2 is divided by 2. And that will get us all the way back up to our variable all by itself, which is just going to be a. All right, so if we try this problem, we'll find out what a equals all by itself. So the very first thing we need to look at is minus 4. We're going to subtract our 4 from our positive 4. If you're ever unsure of where you need to subtract 4 from, you can look at your table and it tells you where you need to subtract 4 from. So because it's right next to the plus 4, you know you need to subtract 4 from the plus 4. But we also know that what we do on one side of our symbol, our inequality symbol, we need to do on the other side of our inequality symbol. 4 minus 4, we get a big ol' 0. We can bring down that 2a. And then 24 minus 4 is just 20. And we're going to bring down that inequality symbol exactly how it is. We're done with that. We're done with those 4s. So now we can move on to our next line, which is 2 times 2. We need to divide 2. So we have times 2. It says we need to divide 2 from our times 2. So we're going to divide 2 from our times 2, but we also have to divide 2 from our 20. 2 divided by 2 is 1, which leaves us with just A. And 20 divided by 2 leaves us with 10. Bring down that same exact symbol, and we get A is greater than or equal to 10. Okay, A is greater than or equal to 10. So what we need to do is we need to make sure that we check that answer. A can be equal to 10, or it can be bigger than 10. So how do we check that? We're going to check a number that is smaller than 10. We're going to check a number that's bigger than 10. Okay, so I want you to do this check. Check the work, and you're going to pick one number that is smaller than 10 and one number that is bigger than 10. Okay, go ahead and check your work. So for the two numbers that I chose to check A equals 9 and A equals 11, because 9 is smaller than 10 and 11 is bigger than 10. And so when I put those numbers in, I got 22 is greater than 24. That doesn't seem right. And then when I put 11 in, I got 26 is greater than 24. That is true. So what our problem says is that A has to be bigger than or equal to 10. Well, looking at our check work, we know that if A is smaller than 10, it doesn't work. But if A is bigger than 10, it does work. So we know that it is true if A is greater than or equal to 10. So on our graph, we are going to say somewhere on here, we're going to put a 0. I like to just put it at the end. We're going to put 0. And then that's just because we need to say where our 0 is. And then somewhere else, we're going to put a 10. I think right here looks like a good spot for 10. And then we need to ask ourselves, is this an open dot or a closed dot? Well, remember, open dots are for strictly greater than and strictly less than, right? They're just greater than or less than. Closed dots are for equal to, greater than and equal to, and less than or equal to. Which one do we have? We have a greater than or equal to. So we're going to have a closed dot. So on our graph, we draw a closed dot up here. And then we ask ourselves, is our number going to go towards 0 or away from 0? Well, we need numbers bigger than 10. So if we go towards 0, are our numbers getting bigger or smaller than 10? If we go towards 0, they're getting smaller than 10. So we want to go away from 0. We're going to head the other direction. Okay? All right, let's try this next one. Ooh. Okay, here is another one for us. So we're going to set up our table again really quick. Okay, so again, on this one, we have our variable, which is b. But this time, the closest thing that's happening to it is this -7. sorry, minus 9. So the closest thing that's happening to our variable this time is the minus 9 because it's in parentheses together. So the very first thing that's happening is minus 9. And then the farthest thing that's happening is this times negative 7. So times negative 7. Remember to write that in parentheses. So then when we find our inverses, it's divide by negative 7 and then plus 9. Okay, now we can go ahead and solve this. We are going to divide both sides by negative 7. And on this side, I actually prefer to write my divide by negative 7 right underneath that 7, because then I can say, oh, it's a 1. And notice I get rid of the negatives. I cover them up with my really weird fancy 1, because then I can just say I have b minus 9 left. And then 84 divided by negative 7 gives me negative 12. And because I divided by a negative, I'm going to flip this inequality symbol the opposite direction. Okay? And now I can add 9 to both sides. Negative 9 plus 9 gives us 0. So we get b is greater than negative 12 plus 9 is negative 3. So b is greater than negative 3. So now we need to figure out a number. We're going to check our work. We need a number that is smaller than negative 3. Maybe, let's say negative 4. And then we need a number that's bigger than negative 3. We could say negative 2. Okay? But it doesn't always have to be the number that's right next to it. We could even go so far as to say 0. Okay? 0 is still bigger than negative 3. So why don't we try negative 4 and 0? Go ahead and check those numbers really quick. Okay, so here we go. We checked it. And when we did negative 4, we got the answer of 91 is less than 84. Is 91 less than 84? No. When we check 0, we get 64 is less than 84. Sorry, 63 is less than 84. And is that true? Is 63 less than 84? That is true. Okay. Let's graph this. Is it going to have an open dot or a closed dot? Well, first we should probably graph our 0. Now, this is a negative, so our 0 is going to go on the opposite side. We can even go so far as to not put it at the end. We could put it here this time. So 0, we need a negative 3. Let's put negative 3 way over here now. It's going to be way over here. We just need 0 on one side, negative 3 on the other. And we are going to have an open dot. So let's put an open circle. And our arrow is going to be pointing because our number is getting bigger than negative 3. So our arrow is going to point towards 0 this time. All right. I want you to try solving the last two. Let's see if you can do that.